Alright, thanks for watching, guys. This is question 6 on stoichiometry as well as empirical formula. For the other questions for this question paper, check out the description box. Now, Lana, we have a 3-part question. 6.1 empirical, 6.2 sikhuluma nge-concentration la as well. Then ku 6.3 sikhuluma ngama-stoichiometric calculations at STP. Now la ku 6.1 bathi methyl propanoate is an organic compound with the following percentage composition. Methyl propanoate. Konje bayibiza on this thing, the propanoate. Methyl propanoate ester, this one. Yes, ester. So okay, uzokhuluma ngawo ka grade 12 kakhulu. This is organic chemistry. So une methyl propanoate la. The molar mass of the compound is 88 gram per mole. Alright, stoichiometry usually bakuphala ma percentages law. Nama percentages law. So carbon in a 54.55%, hydrogen, and then kubanani no oxygen. So this compound basipela ma percentages law, right? And then the molar mass. So in such a case, yabona the moment bakupa molar mass, just know that uzo calculator as well as the molecular formula. It's true formula. The empirical formula is just the formula in its simplest form. Yabona ukuthi ngenzeni lapho. While I was explaining, I was also defining the term empirical formula. So empirical formula, it's the simplest whole number ratio of the elements in a given compound, of elements in a given compound. Here we go. This is the definition in empirical formula. It's the simplest whole number ratio. It's not the true formula, but the empirical formula, the simplest formula of the given compound. Now, sizalago 6.1.2, wherever this is calculated, the empirical formula. Lama percentages lawa swatata as ama masses because of stoichiometry tina. See calculator using a 100 gram sample. So therefore that's why now uthola 55.55% of 100 gram you total of 55.55 grams as your mass. Hydrogen you total 9.09 grams, 36.36 gram of oxygen, because of we take a 100 gram sample and use that to calculate. So senzani ke kokuqala, we need ama moles. We need the number of moles for each element. Mass over molar mass. So siqale number of moles for a carbon is equal to, it's the mass, which is 54.55 divided by, what is the molar mass here carbon? It's 12, equal to, then we calculate. Load the calculator. Let's also write down the formula for finding a molar mass, the number of moles for a hydrogen, which is 9.09. The molar mass of hydrogen is 1, equal to, so I answer already here, so 9.09 mole. Lela pa phezulu 54.55 divided by 12. It's 4.55 mole. Then siba a number of moles, it's hydrogen la, the number of moles for oxygen, which is 36.36 over 16, equal to, divided by 16 is equal to 2.27. in 2 decimal places. 2,27 mole. Okay. So since the empirical formula, it's actually the what is this? It's actually the simplest whole number ratio of elements in a given compound. Then you take a number of moles for carbon, we compare with the number of moles for hydrogen, we compare with the number of moles for oxygen. So 4,55 la, sibe no 9,09 la, sibe no 2,27 la. Alright, okay. So what do we do next? Is for now calculate the ratio between lama elements we 3. Siyenza njani ke? Sithatha the smallest value out of the 3 number of moles. Divide each number la ngayo. 2,27. This divide by that is power 1. Siyabuya sithi 9,09 divided by 2,27 is equal to 4. And then siyabuya sithola the answer for this one, 4,55 divided by 2,27 equal to sithola u2 la. So our answer is going to be carbon, it's 2, and then hydrogen, it's 4, oxygen, it's 1. So this is our empirical formula. Then siyabuya ke manje, but alright. Yabona we calculate the empirical formula, but also calculate the molecular formula. Mr. Examiner, uthini manje? Sengikhohliwe this thing, I mean. Alright, you know what again? You need to take the ratio of molar mass to the empirical mass. To the empirical mass. Empirical formula mass. Empirical formula mass. So what is the molar mass? 88. How about the empirical formula molar mass? The empirical formula is it's C2H4 then O1. So the molar mass for the empirical formula, it's 2 times 12 plus 4 times 1 plus 16. Sitolangaki 44. So it's 44. 88 over 44, it's what? It's 2. So basically to find the molecular mass, tata your empirical formula 4, then 1, then you multiply by the 2. This number you told the ratio between the molecular mass, the true molecular mass, divided by the empirical formula mass, it's actually a factor. Also the whole exercise was to find a factor, also multiply ngayo the empirical formula so that you told the true molecular formula. So this factor itola si multiply ngayo si tola 2, so 2 times 2 it's 4, so it's C4. 2 times 4 it's 8. 2 times 1 it's O2. This is our molecular formula. Second part of the question, learners prepare a solution of sodium hydroxide in water by placing 8 grams of sodium hydroxide in a volumetric flask and adding water to produce 250 cubic centimeters of solution after stirring. Then it's a question, just a simple question and a short one on concentration, solutions basically. So so what is described in concentration? It's the amount of solute the amount of solute, the amount of solute per liter of a solution, kanjalo nje. This is concentration, amount of solute per liter of in a solution. So a concentration, angisho uyazi ukuthi nasiprepare a solution udinga a solute, something like a solid nyana. So, okay, let's take angazi ukuthi niyayazi lento bathi umpupudla angazi ukuthi libiza kahle nale gama. Starch water, thatha ishukela uyithele emanzini warm, uyastera, uyayiphuza this thing. It's very good for you, it's very good. Okay, right, then uthatha ishukela, sugar is solute, amanzi warm, it's what? Solvent. So what is concentration? Is the amount of solute per liter of the solution, right? So concentration determine ukuthi kunama solutes angakanani ngaphakathi we solution. Alright, okay. Then 6.2.2, calculate the concentration of the sodium hydroxide. So lana basiphe 8 grams of sodium hydroxide, adding water to produce 250 cubic centimeters of solution, right? So we want to find e concentration again, Angela. So the concentration is equal to mass over molar mass times E volume. But when I calculate it this way, concentration is concentration over number of moles over volume, is it? Number of moles over volume. Yeah. So it's number of moles over volume, or mass over molar mass times E volume. So sebenzisa the first equation, not the second one. Ngoba we don't have the number of moles, but instead basiphe ini mass. We can also convert the mass to a number of moles, then substitute back into this equation. But it's way simpler nangabu usebenzana this one. Ngoba une mass anyway, asi substitute 8 over the molar mass ya sodium hydroxide komele si calculate. So the molar mass kuba ubali sodium ngathi it's 23. Let me see, 23, 16 plus 1. Sorry, it's 40. So therefore it's 40. Right, and any volume, remember we only work with cubic decimeters. In this exercise we work with cubic decimeters. When calculating a concentration, your volume must be expressed in cubic decimeters. So it's 250 cubic centimeters is equal to 0.25 cubic decimeters. We divide that by 1,000. We total this 0.25 equal to, so let's see, 4 times 0.25. Answer is 0.8 mole per cubic decimeters. Alright, now I answer it okay, guys. Now to the last part of the question, 6.3. Banyakang sodium azide. Nyaqala ukuyibona le substance le. Sodium azide is used in car airbags. For the airbag to inflate, the following reaction must take place. The sodium azide decompose form sodium then nitrogen gas. Calculate the volume of nitrogen gas that would be produced at standard temperature and pressure if 55 grams of sodium hydroxide reacts completely. Stoichiometry at standard temperature and pressure. Now see approach kanjani. So the first thing, whenever you deal in stoichiometry, if you actually a question Okay, kwamele ingakushayi man, kwamele ingakushayi. But one thing you should know is that all masses must be converted to moles. Mass over molar mass. You're totally mark for look. For just converting this 55 gram sodium azide, it's 23 plus 3 times, isn't it 14 65, yeah, it's 60, it's, yeah, it's this one, yeah, it's 14, nitrogen is 14, so it's 65 equal to, so the first thing oyenzayo na get 55 over 65, 0.85 moles of sodium azide, yes, of sodium azide. So alright here, okay, it's a mark, follow, it's a mark. In things before you can perform any stoichiometric calculations, you need to make sure that all your masses are changed to moles. The stoichiometric calculations, we can only do them with moles kuphela, not masses. Ne? Alright, okay. We also have a chemical reaction, right? A chemical reaction. So a stoichiometry calculation, sisebenzisa the ratios, the coefficients esiwathola la kule equation yethu le. Right. Calculate the volume of nitrogen. Ikuphi nitrogen? Nyla. Show that calculate the volume of nitrogen gas that would be produced at standard temperature and pressure if this of sodium hydroxide is given, 55 gram of sodium azide is given, right? So sinale mass le, it's a given. Find mass, I mean the gas produced, the nitrogen gas. Yes, so sifuna the volume of this nitrogen gas. How do we do that again? So yizwa basiphe nitrogen sodium azide, basiphi sodium azide in solid form. Si compare ne nitrogen gas, la. So nitrogen sodium azide to nitrogen gas. Bheka ke manje, you need the ratios from the equation. It's 2 to 3, right? And then bheka ke manje, bheka. Yabona ama ratios are powerful, are very powerful, bheka la. Siceda ukukhalculate the number of moles for sodium azide reactile, right? So lena na reactor sodium azide na reactor iyo producer ini nitrogen gas. So sifuna ukwazi ukuthi if this amount of sodium azide reacts, yofomeka how much of nitrogen gas. Le answer soyithola la angeke kube volume, but instead kuba the number of moles of nitrogen gas that will be produced. So now that I have the ratios in place, now I cross multiply and solve for x. 2x equal to 3 times 0.85, divide both sides by 2. X is equal to, then go 3 multiplied by 0.85 divided by 2. Answer is 1.275. Atinyekele le answer. These are the number of moles wani when nitrogen gas azoba produced. These are the number of moles of sodium gas that will be produced. So since nginale number of moles nitrogen gas at standard temperature and pressure, but is calculated in volume at standard temperature and pressure, siyazi ukuthi the number of moles are calculated as volume over molar volume. So I just substitute the equation and find the volume produced. So these are the number of moles, 1,275 for a nitrogen gas. Volume produced unknown. At standard temperature and pressure, the molar volume go about 22,4. In case guphi formula sheet, just make sure ukuthi uyakwazi lokho. Uyayazi molar volume, all the constants in fact. Then you cross multiply. V times 1 is V, then 1,275 times 22,4. Volume is equal to, in case awuyiboni lana, the final answer na it's 1,275 1,275 multiplied by 22,4 is equal to 28,56. 28,56 cubic decimeters. Cubic decimeters. This is our answer again. This is our answer. Lana 5 6.3, and the last question question 6. Guys, please, nangabe uthola some value out of my content, please leave a like, asikhulume in the comment section. Nangabe une question, ungakhohlwa ukushare nokusubscribe. So for now guys, please asibonane on the next recording. So for now I'm signing out. Bye bye.